a look at our tips for solving trig proofs. Okay, so we've kind of already talked about this a little, but it's just a good time to review. We said always start from the more complex side. We always start from either the left hand or the right hand side and apply the identities step by step until we reach the other side. Like I said, we're trying to just work one side and prove that it equals the other side. It's a lot easier to reduce a more complex function than it is to take a simple function and make it more complex. So we want to start on the harder side and try to get it to equal the simpler side. In today's proofs, there are going to be a couple that you can work either side pretty easily, pretty straightforward. Like there may be one or two of those. So sometimes either side is okay. As long as you get it to equal the other side, you're okay. All right. Second, change everything in terms of sine and cosine. We've talked about that. That's a frequently used tip. Okay, especially when you can't use the Pythagorean identity. Step 3, use Pythagorean identities to change a side into the needed trig function. Okay, so pay special attention to the addition of squared trig terms. When I see squared, I automatically start thinking Pythagorean identities. Not that we'll always use them then, but just I at least consider them. Especially sine squared theta plus cosine squared theta equals 1. If we're changing everything to sine and cosine, then we'll see that a lot. These identities can be used to convert one trig function into the other, or can be useful in removing both and turning them into a constant, turning them into 1. Okay, and we're going to see that in our proofs today. Our proofs today are going to focus on reciprocal properties, Pythagorean identities, and then algebra. Number 4, know when to use double angle and sum and difference formulas. I don't think we're going to have any of those today, but if you have regular theta and you have 2 theta, you're going to have to use your double angle formulas to switch, to get them to either all be 2 theta or get them to all be a single theta, okay? And then the sum or difference formulas. We'll see examples of that later in the unit. Make use of your algebra skills, factor, FOIL, simplify, cancel, okay? Think the problem through one step at a time, meaning that proofs require you to take it as you go, okay? When you're working, you often don't know how you're going to finish and if it's going to work. And so that's what I said, you just got to be brave and walk into the forest. We don't know how we're going to get out, but we're going to walk into the forest. We can't get out until we go in. So just get started. Reference frequently where you're heading. So take a look at what you want and see if this looks like it's getting you closer there, but don't be too worried, okay? And then lastly of all, practice, practice, practice. We learn by doing. As I work these proofs today, they're going to seem pretty logical when you watch me do them, but you'll find when you try to do your own, there's a little more time and space. It really does take practice to get these right. So let's give some a try. Let's get started. Okay, so this first proof says sine theta over tangent theta equals cosine theta. The more complicated side is the left side, so that's what I'm going to work. I've got sine and tangent, and I want cosine. So first thing I'm thinking is change everything to sine and cosine, because I want to be able to get rid of that tangent. So let's try it. And as soon as I get my pen tools up. Okay. So we've got sine theta over 1 over sine theta over cosine theta. Okay, so that's our first step. The equal sign is still on the right because we're working the left side. Next step, I'm going to multiply by the reciprocal to divide a fraction by a fraction. So that's going to be sine theta over 1 times the flip of that fraction is cosine theta over sine theta. Was that helpful to me? Yes, because now the sine theta over sine theta cancel, and I have cosine theta, which is what we wanted. We did it. We did it. Okay, so now it's your turn. Give that second one a try. Then I'll be watching what you do. If you get stuck, let me know. Okay, we're starting easy for you. Okay, so let's give it a try and see how you do. Remember, working in Pear Deck will let me help you if you get stuck. Okay, remember you can type it in the chat and let me know if you're stuck, and I'm happy to take a look at yours. Code is there in the corner. If you're typing, I wouldn't normally let you do this, but just to speed you up, you can use X instead of theta. We don't, in a problem, we use whatever variable they give us. So we don't normally change that, but I see some of you are typing your proofs and I know it'll be faster for you. I'd rather you type sin X than leave it as sin, because remember we said it's never a sin to do math, right? Remember, we do want equal signs between steps. Okay. Good. Very nice. Okay, so you want to do a check at the end to show that you have proven what was to be proved. You can also write QED, which stands for quod erat demonstratum, which is Latin for that which was to be proven. So QED is also an abbreviation you'll see often at the end of proofs. I just like a check mark. It's fast and easy. It says, I've done it. This is it. Okay. Smiley face is optional. Ms. Weaver likes to do that because I like to celebrate my successes. Okay, let's take a look at Yassine's real quickly. You did a good job on this. Yassine, can you talk us through what you did there? Let's see. Am I sharing? Just one second. I'm not sharing. There we go. Okay, talk us through that.
So what I did was I changed both the tan and secant into sine or cosine. And for tan, I got sine theta over cosine theta, and secant was 1 over cosine theta.
Perfect.
And I multiplied sine and divided by cosine times the reciprocal of 1 divided by cosine. And I got sine theta cosine theta over cosine theta, and I just
you said over, but you meant times.
Yeah.
Good, very nice. And then it's simplified. Like I said, starting not too bad. So thank you, sir. Let's try our next one. Okay. So this one says cosine theta secant theta over tangent theta equals cotangent theta. So I've got cosine, secants, tangents, and I want cotangents. Okay, so I've got all these different functions. This is a great time to switch everything to sine and cosine. Okay, I know y'all are probably feeling like we're one-trick ponies with so much of that, but that really is, that's when you would want to do that, when you've got all these different functions and you want to get it to another function. So that would be cosine theta over 1 times 1 over cosine theta divided by, now I've got tangent theta in the denominator and I want cotangent theta. I could change it to sine over cosine, I might, but I'm thinking let's just leave it as tangent theta in the denominator right now because I know cotangent is 1 over tangent. So I'm thinking that might be what I need, okay? And that's my reasoning for thinking. It's no big deal if you switch it now and have to switch it back because you can. In the next step, you can just switch it back if you want it back. But that's my reasoning for deciding not to switch it right now because I always keep an eye on where I'm headed to see what do I think, okay? And now that I look at that numerator again, I'm like, perfect, because cosine over cosine will cancel. I do need my equal signs. I'm used to putting them out front, and when we work the left side of a proof, I put them in the middle to make sure I know that that's the left side that I'm working. Okay, so let me go ahead and write that there. Cosine over cosine will cancel. That will give me 1 over tangent theta. And I was hoping that would happen because 1 over tangent theta is cotangent theta. We did it. We did it. Okay. And so like that's, I love the Dora celebration because we found our way through the path. We got out of the forest. Okay. Now you guys try the other side. You give the other side a try on your own. Let's go. Let's see what you can do. And because you have not all tangents and cotangents, I would really recommend changing everything to sine and cosine. So even though cotangent is 1 over tangent, I would probably go ahead and change everything to sine and cosine, because then it will be easier to have things simplify and cancel away. Or Sanjita, you can save yourself a step if you go ahead and just write that directly as cosine over sine. So it is 1 over sine over cosine, but it's also starts with cotangent is directly cosine over sine. You can still get there the way you're going, but it'll just take an extra step. If you don't understand what I'm saying, no problem. Just keep working it the way you're working. You'll get there. That's the other thing, guys. There's not a wrong way to work a proof. If you work it and get there, then you've proven it. Okay, as long as you take correct steps, you've proven it. So don't stress yourself out about, was there a better way? I may try to give it tips while you're learning, but as long as you end up there, you're good. Okay, so Jay, let's have you talk through yours. I'm going to need you to show another step because it is not yet quite clear, but you've got some good work going on there and good thinking. So I want to go ahead and share it and have you talk us through it. We'll clean it up a little bit if we need to. Okay, so can you talk us through your thought process there?
So if you're growling, just a warning because my dogs are in here. But basically, no, but I knew cotangent was cosine theta over sine theta.
Good.
So I converted it to that. And then secant is 1 over cosine theta.
Yeah.
So I just did that
Okay.
over cosecant of theta.
Mhm.
And then I knew the cosines canceled out. And so I did 1 over cosine theta over cosecant. And then I think the step I missed was cosecant over cosecant.
And that's what I was going to say. There's more than one way to do it, but in here I need one more step, okay? Because I just need to know, because it's not obvious looking at it. We know that anything over itself equals 1, but I do need that step. And you can either do it as what you just said, which was cosecant theta over cosecant theta, because that'll work, because we do all know that that numerator does equal cosecant. So cosecant over cosecant would equal 1. Or you could change the denominator to 1 over sine as well. And then 1 over sine over 1 over sine would also equal 1. So either one of those will work, but you're right. That is the extra step I was needing, just inserted there. So good job. Okay, any questions for Jay about that? Excellent, amen. Okay, let's try our next problem. And okay, so now this one I have put on separate slides. This is going to be our proof that takes the most steps, and you do have one similar to this in your minor summative today. So I gave us a little more room to work on this. Okay, we may need more than one column. So it says tangent theta over cosecant theta equals secant theta minus cosine theta. Okay, so let's talk about what's different about this proof. Looking at this proof, I know it might take a little extra work because we have a single term on the left and we have 2 terms on the right. Okay, now this is one of those proofs that I said you could work either side depending on what you think is easiest. My first thoughts are, I'm going to work that left side. And I say that's my thoughts. I should look at which way I worked it first. Yeah, I'm going to work the left side and try to get it to equal the right side. If you want to try the right side, I've got both ways worked out on the answer document in the folder, so you can see both ways. And I'm happy to go over both ways in class. But I'm going to try the left side and see if we can get it to equal the right side. Now, just a little heads up and tip. Where do we see minus signs in anything that we know yet? Most of our properties are just substitutions for each other. They're just equivalencies. Where do we see minus signs? With our Pythagorean identities, right? So if we can get something to be squared, then we can go look at our Pythagorean identities and maybe introduce a minus sign somewhere. Okay, so let's just kind of work and see what we can do. Okay. Okay, so I am going to change, because I've got tangents, cosecants, secants, and cosines. I'm still going to go ahead and start with that strategy of changing everything to sine and cosine. So tangent is sine over cosine. See how I make my big fraction bar there for the middle so I can tell what's my numerator and what's my denominator? Cosecant theta is 1 over sine theta. Okay, so that's my first step, just changing everything to sine and cosine. In my next step, I'll go ahead and multiply by the reciprocal. So we'll have sine theta over cosine theta times the reciprocal of 1 over sine theta, which is sine theta over 1. Okay. Now, things didn't cancel away like in some of our other proofs, but when we multiply numerator times numerator and denominator times denominator, I get sine squared theta over cosine theta. Okay, and that's actually what I was kind of hoping for, because the squareds can let me change to Pythagorean identities. Okay, so let's look at our Pythagorean identities. So which one has sine squared in it? Only one of them has sine squared in it. Okay, the one that has sine squared in it, and this is a little aside, this is not part of my proof. The one that has sine squared in it is the one that says sine squared theta plus cosine squared theta equals 1. Okay, we need to substitute for just sine squared theta. That's the term we have by ourselves. So can you algebraically manipulate this to see what sine squared theta is equal to? Some of you can just do that in your head, just looking at that, you can see it, but we can also write it out as well. If I subtract the cosine squared theta from both sides to get sine squared theta by itself, that'll be sine squared theta equals 1 minus cosine squared theta. Okay, now I still just said what I did. Some of you may want to actually write out that step where you subtract cosine squared theta from both sides, and that's okay. If you want to write it out, that's totally okay. When in doubt, write it out. Showing more steps helps remind you where it came from. Those cancel, and we get sine squared theta equals 1 minus cosine squared theta. Okay, that is not part of our proof. That was just work I did on the side to remind myself what I can substitute for sine squared theta. Okay, so what we can substitute for sine squared theta, in my next steps, I'm going to draw a little arrow to say this is my next step. Okay, I don't want to confuse anyone with the equal signs when they're trying to follow my proof. My next step is going to be, instead of sine squared in the numerator, I'm going to write 1 minus cosine squared theta over cosine theta. Okay, I'm still putting my equal sign on the right because I'm still working the left side of the proof. Everybody okay with that so far? Okay, now let's look at where we're at and let's look at where we're headed. Okay, we need 2 separate terms. Right now I have 2 terms in the numerator, but they're written over a common denominator. Just like we can put terms together over a common denominator, we can separate them over a common denominator. So let's do that. Let's separate these 2 terms and write it as 1 over cosine theta minus cosine squared theta over cosine theta. Do you see what I did there? I just wrote both terms separately over their common denominator. You're used to going the other way. You're used to seeing that fractions have a common denominator and writing them together over the common denominator, but we just separated them, writing them separately over that common denominator. Questions for me about that? Let me know in the chat or unmute and ask if you've got questions, okay? All right, next step, we're just going to keep going with our algebra and simplify. I've got 1 over cosine and I want secant. 1 over cosine actually is secant, so I can go ahead and change that to secant minus, what is cosine squared theta over cosine theta? Well, one of the 2 cosines on top cancels with the cosine on bottom, and that leaves me a plain cosine theta over 1. If my denominator is 1, I don't have to write it. So I've got secant theta minus cosine theta, and we did it. We did it. That's what we were trying to prove, okay? So sometimes it sneaks up on you like that. You're in the middle of working hard, and then all of a sudden you're there, and that's exciting when you get it, okay? Questions for me about that? All right, so this might feel a little challenging or scary, but you can do it. We're going to let you do a similar proof on the next slide. Would anyone like to see that worked with the other side? Did anybody try to work the other side? Would you like to see the other side worked?
Miss Weaver, can you go back this slide?
Sure.
I just want to.
Okay.
Thank you.
Yeah, because I want you to have an example like that down, because you're going to do something similar right now. I think for fun, I'm going to show you working the other side, but let me give you a chance to get those steps written down. Just because it's kind of good to see the algebraic manipulations, what we can do and how they can work out. So we're doing good on time. So I'm going to go ahead and show this one working the other side. Tell me when you're good, Noah, and then because I'm going to delete my work and show work.
Good.
Okay. All right, so I'm going to work the same proof, but I'm going to work the right side. Okay, so same idea here. My equal sign is going to be on the left side now because I'm working the right side. I left a little space for the left side, and I'm going to change everything to sine and cosine again. So secant will be 1 over cosine theta minus cosine theta will be cosine theta over 1. Okay, now what I notice when I'm starting this, I've got 2 terms and I need to get them to a single term. I've got 2 terms and I need to get them to a single term. So the first thing I want to do is I want to get a common denominator. So I'm going to multiply this term by cosine theta over cosine theta. Okay. Now I have to say, in grading you guys' your Delta Math proofs, I believe it was, or maybe it was your study guide. I think it was the study guide. In grading your study guides, a lot of you had the correct ideas, but the modality of your proofs were not quite laid out right. The work wasn't quite shown right. So hopefully with this part of the unit, we'll really get solid on how to show our work. Remember I said what you cannot do is work across the equal sign because we have not shown that the 2 sides of the equation are equal. So I couldn't multiply the whole equation by cosine theta, but I can definitely multiply this individual term by cosine theta over cosine theta because anything over itself is 1. So I'm really just multiplying this term by 1. I'm going to change its appearance, but I'm not changing its value. So that is completely legal. Okay, that's completely legal. Okay, so that gives me 1 over cosine theta minus, that's going to be cosine squared theta over cosine theta. Okay, so now in my next step, I have a common denominator. So I can write those terms together over that common denominator. So I can make my denominator cosine theta, and that gives me 1 minus cosine squared theta over cosine theta. Okay, and I'm feeling good. I've got it down to where it's looking a little more like one term, and I see those squareds. So anytime we see squareds, we're going to consider our Pythagorean identities. So in the little scratch paper to myself, I'm thinking about my one that has cosine squared theta in it, and that's the sine squared theta plus cosine squared theta equals 1. Okay, so if we subtract sine squared from both sides, I can get that cosine squared theta equals 1 minus sine squared theta. Okay. Okay, but I've already got, sorry, that's true, but that's not what I want to do there. Okay, when I went and compared that to what I have in my work, that's not helpful because that's not what I have in my work. What do I have in my work? In my work, I have 1 minus cosine squared theta. So instead, let's subtract the cosine squared theta from both sides. And that should be helpful because I need it to match what I have in my problem. So see, mistakes are no big deal. You just reevaluate and then try it again. So that'll give me sine squared theta equals 1 minus cosine squared theta. Okay, so now when I have 1 minus cosine squared theta, I can substitute in for that. What is 1 minus cosine squared theta equal to? Sine squared theta. And once you've been working with these for a little while, you'll start to learn them. But for now, we just look at our formula sheet and we have them written off to the side and we refer to them to help us see how to manipulate it in our head to change it. Okay, I've got it down to 1 term, so I'm feeling good. So now I totally have to come look at where I'm at and where I'm headed. All right, so we've got sine squared theta over cosine theta. We need a tangent and we need a cosecant. All right, so how to split this. I'm going to go ahead and move to another line here. So I'm going to show Then I'm coming up here and starting again. I'm actually going to erase this because I think we may still have a little bit of work to go. So I'm going to try this instead. Okay, so we'll go right up here to the top. Okay, so I'm going to split that as, so right now it's sine squared theta. And so I know that that's a sine times a sine. And so let's just start it. I'm not sure how to split it, so let's just split it. So I'm going to do sine theta over cosine theta times sine theta over 1. Now notice that this is different than when we split two terms over a common denominator. This is a single term, so you can't have a plus or minus sign in between. This is numerator times numerator and denominator times denominator. So sine squared is sine times sine. Cosine theta, it looks like it's just by itself, but we can always put a 1 there to multiply by it. Okay, so what does that give me? That gives me a tangent theta times a sine theta. And I'm going to leave that as sine theta over 1 because when I went to look at what I'm looking for, I do want a tangent theta, but I want it over a cosecant theta. Okay, so why would I leave that over 1 if I want it to be cosecant? Can anyone imagine what step we want to take here next? Any thoughts or ideas? And it's okay if you don't see it yet. Like these are emergent techniques that we're working on. Sarah, do you have an idea? That's right. So we multiply by the reciprocal when we divide by a fraction. So if I change this in this next step to be tangent theta divided by, now it'll need to be the reciprocal of that fraction, which is 1 over sine theta. Okay, if we flip it back the other way to dividing by a fraction, okay, that's the same as multiplying by its reciprocal. We're just going backwards there. And now we are almost there. So now I'm super happy because tangent theta over 1 over sine theta, 1 over sine theta is the same as cosecant theta. And after much work, we did it. We did it. Do you see why I like to celebrate? After all that work, you need to celebrate, right?
Miss Weaver?
Uh-huh.
So it's okay to leave tan theta and not transfer it into sine theta over cosine theta? Like you can just put it back to tan theta?
Yes, we actually came from sine over cosine and made it tangent. We were trying to get the left side now, so we needed it to be tangent. So yes, those are fluid substitutions that work both directions. So it just depends on what you're going for.
Okay. And then also, when you did the 1 minus cosine squared theta, and then that equals sine squared theta, is that on that sheet about like the rules?
So it's not on that sheet, but it was on our opening slide, and it's on your formula sheet from the first day 1 of this unit. So if you go back to day 1 when we did sums and differences, here, let me get this screen off just 1 second. So here on the opening slide there at the bottom, we have the 3 Pythagorean identities. And remember, the first one is the one that you should have memorized. The first one is the only one I have memorized. But I remember that the other 2 come from dividing it all the way through by sine squared theta and then dividing it all the way through by cosine squared theta. So usually when I'm working trig proofs, I will write these 3 out at the top of my page every time I'm working trig proofs so that I can refer to them. Because I only have the first one memorized, but you often need all 3 when you're working trig proofs, okay? So I really recommend writing those out at the top of your page so that they're quick and handy to reference.
Okay, and then to get like the exact thing, you can just like move it over because like it doesn't actually say like 1 minus cosine squared.
You're right, it doesn't, but it's a true equation, so you can manipulate it algebraically and generate other true statements that you can substitute. You sure can.
Okay, thank you.
All right, and so there was a question from Valerie in the chat. How did you go from tangent times sine theta over 1 to tangent over 1 sine theta? Let's go back and look at that again. So oh wait, let's okay, so this is where I asked you, Valerie, to think for a second, okay? So I was looking at where I was at here in this pink step. We're at tangent times sine theta over 1. This is what we've been able to get to so far. But then keep an eye at where you need to be. So looking at where we need to be and where we are. I've got tangent times sine theta over 1. I need tangent divided by cosecant theta. And so I'm trying to think, is there any way to get from tangent times sine theta over 1 to tangent over cosecant? And that's where Sarah was telling us, okay, that she knew that we multiply by the reciprocal when we're really dividing by a fraction, So she rewrote it as tangent theta divided by the reciprocal or flip of this fraction. Okay, so the flip of that fraction is 1 over sine theta. Can you see, Valerie, that if we had the blue step here, we could go to the pink step, because to divide by a fraction, we would multiply by its reciprocal. Can you see?
Oh yeah, I see it.
Right. So now it's that idea that we can go either direction. And that's why, like, the first side that we worked was kind of easier. It seemed more natural, but we could still do it this way. It just was a little bit harder. Okay. And it's still good to see these steps going in reverse, because sometimes you may be in a proof where you need to do that. So starting to see that you can do it, it's mind expanding. It helps you see new things. Okay.
Thank you.
You're welcome. Okay. So now let's let you guys try your version of that problem. So let's take a look. Okay. Prove the following identity. Cosine theta over secant theta times sine theta equals cosecant theta minus sine theta. I'll tell you, I worked the left side. Okay, I think it's a little easier. It looks like the more complex side. Okay, and so we usually try to work from the more complex to the simpler. Let's have you go ahead and give that a try. Let's see what you can do. Zach, all day, sir. I hate it too. I have glasses. They fog up. It's brutal, but. My friend who I walk with 2 days a week, we've been wearing masks all pandemic. She just got her second shot. So in 2 more weeks, we get to walk without our masks because we're both fully vaccinated. I can't wait. We'll be outdoors and fully vaccinated. Yeah. Good try. Sure. Did we already did this one? The one that we did before. It should be, no, because this is the one that we did before. So then this is the one you're doing on your own. Copied it in the wrong place when I did the other version. Okay, so that second time was me working the same problem on the other, working this side of it. Okay. So this one, you can just like maybe mark that off the side and start working it here. Try to work this one on your own here. Okay. I know it's tough. Don't get discouraged. Show me your stuff in Paradox so I can see where you're at and we can kind of help you along. Now, super important to remember. Your Pythagorean identities are only for sine squared, cosine squared, cotangent squared, cosecant squared, tangent squared, secant squared. You can't change a regular sign to the other, okay? We don't have an identity that says sine theta plus cosine theta equals 1. It's got to be squared, okay? So be careful about that. Let's try this. Okay, good. You looking for your notes, Emily? Yeah. It says, so the one I want you guys to all have memorized, and you can write it at the top of your page, is the one that says sine squared theta plus cosine squared theta equals 1, okay? And then that you can manipulate that one. Okay, so I'm going to start just a few steps, or actually, Emily, if you don't mind, I'm going to share yours and let us talk you through your few steps so far, because we have some people that are a little bit stuck, and I know you're not finished yet either, but it'll let us kind of get people going a little bit. So let's take a look at this for a second, and then we'll let everyone try to take it from there. Okay. So tell us what you saw, what you were thinking, Emily.
So for the numerator, I just put cosine over cosine theta over 1.
Okay.
It's itself.
Uh-huh.
And then I changed the denominator to in terms of cosine and sine.
Okay.
So secant is 1 over cosine, and then sine is sine over 1.
Good. Okay.
And then for the next step, I just kept the cosine theta over 1 divided by, and then I canceled the 1s.
Right.
So then it's sine theta over cosine theta.
And another way to think of that is also just multiplying it. So that both ways are correct ways to think of it and work. Okay, so you've got sine over cosine. Okay, so we're going to follow your arrow up to the top of the second column. And what did you do then?
I multiplied by the reciprocal.
Okay, so to divide by a fraction, you multiplied by the reciprocal, so you flipped it. Okay.
And then I just multiplied across, so I got cosine squared theta over sine theta.
And that's the right way to write this. Cosine theta times cosine theta gives you cosine squared theta. The squared goes on the word cosine and not on the theta. I saw a few people putting it on the theta. It goes on the cosine part. It's the cosine value that's squared. Okay, she's not there yet, but she's well on her way. Okay, she's got cosine squared theta over sine theta, and this is where she started thinking about her Pythagorean identities. Remember, on this left side, we're starting with a single term. And I say that because terms are separated by addition and subtraction signs. So there are no addition and subtraction signs here. So this is one term. But we've got to get it to 2 terms. We've got to introduce a minus sign. So what do we know about cosine squared theta? If you look at that, Emily, could you manipulate it to get cosine squared theta by itself?
So it would be cosine squared theta equals 1 minus sine.
Okay, very nice. Okay, so if we make that substitution into the formula, do you want to keep working for us, Emily?
It would equal, the numerator would be 1 minus sine squared theta over sine, sine theta.
Okay. All right, so we've got a minus sign in there, so we're making good progress. Okay, but we need 2 separate terms, and right now we have 2 terms written over a common denominator. So how can we separate those into 2 completely separate terms?
So I would do 1 over sine theta, and then minus, to keep the minus sine squared theta over sine theta.
Okay. And let's wait just a second. Let's let people kind of catch up. So let's kind of take a second to look at that. Okay, so both terms are written over a common denominator. So we just wrote them separately over that same denominator. Remember with fractions, if they have a common denominator, you can write them together, but you can also separate them, okay, separately like that. Okay, was that helpful?
Yeah.
Okay.
Because then you can see that 1 over sine theta is equal to cosecant.
Cosecant theta, and that's one of the ones we're looking for. So when we look here, we're like, okay, it's that feels better. Okay.
And then keep the minus sign.
Mm-hmm.
And you can cancel the denominator with 1 of the signs.
So that sine theta on bottom cancels with one of the 2 sine thetas in the numerator. Mm-hmm.
And then it will just equal sine theta. And then that's
She did it. She did it beautifully. I'm going to add a little star to your smiley face. Very nice, ma'am. Okay, that was hard work, but good work. Questions for Emily on that one? Don't be surprised if you struggled with this one. This is a pretty involved proof, lots of algebra, good substitutions, but this is how we're going to build that fluidity with it. There is one like this in your minor summative. So make sure that you have good notes on this and that you're ready to give it a try again. Okay. If you get stuck on your minor summative, make sure and ask. I stay in the Google Meet to take questions. Okay. So if you need help, let me know. I'm happy to help. Okay. Questions about that one? Do we need a second to copy it down as an example? Okay, no problem, no problem. Because when we're talking it through, I really want you following us and thinking about it. You know, I know we're busy trying to take notes as well, but I want you to make sure you follow the discussion and understand the steps. And then we can always wait a second for you to copy it down if you need to.
I'm good now.
Okay, thank you, sir. Everybody else good? Okay, let's try our next problem. Okay, so this is, let's see. Okay, so this says cosine theta over secant theta plus sine theta over cosecant theta equals 1. So it looks pretty complicated to start, but I can tell it's going to all simplify down to 1. Thoughts or ideas on how to start this one? I see Jay is not wasting any time. She's going for it. And that's what I would do too. So I would change everything to sine and cosine, right? Because when everything's sine and cosine, it's more likely to be able to simplify or cancel. So let's give that a try. I know I said I'll work the first one, so I will. I just thought I'd give you guys a chance to try it. I got to get plugged in a second before my device dies. We can do it. We can do it. Let's see, did it change? It's so funny because it tells me it doesn't recognize me with my mask on. Okay, let's go. We'll try. Okay, maybe we can do it like there. Okay. So cosine theta, I would just go ahead and write that as cosine theta over 1, just turning it into a fraction. Over secant theta is 1 over cosine theta plus sine theta would be sine theta over 1 because it already is sine and cosine. Cosecant is 1 over sine theta. Okay, so that's my first step, just changing everything to sine and cosine. Okay, I probably should have tried to write smaller. We'll see if we can do that now. Okay, so in this first step, when I multiply by the reciprocal, I have cosine theta over 1 times cosine theta over 1, because when I multiply by this reciprocal, that's what I get. Plus, in the second term, we have sine theta over 1, and when I might multiply it by its reciprocal in the denominator, that's going to give me sine theta over 1. Okay, so all we did was separately, we multiplied each fraction by the reciprocal of its denominator. Everybody okay with that so far? Okay, that gives me cosine theta times cosine theta is cosine squared theta. 1 times 1 is 1. If my denominator is just 1, I don't have to write it. Plus, sine theta times sine theta is sine squared theta. 1 times 1 is 1 in the denominator, but if my denominator is 1, I don't have to write it. Okay. And was that helpful? Well, we want it to equal 1. I see my squareds now, so I think about my Pythagorean identities. And we have a Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. So even though this is in the wrong order, this is cosine squared theta plus sine squared theta, it still equals 1 because addition is commutative. 3 plus 4 is the same as 4 plus 3. You can change the order and it doesn't change the answer. So we did it. We did it. All right, you guys are up to that next one. Let's see what you can do. Questions for me before I turn you loose on that second one? Okay, it's there for reference for you to look at. Go ahead and try that other side. Go ahead and try that other side. Okay, so with those separate fractions, you can still multiply them separately by their reciprocal. Okay, so these are more just kind of algebra problems. Okay, so they may not look like an exact mirror image, but they're still using kind of those same principles. Alex, can you help me get started on this? If I just want to change everything to sine and cosine, what will that look like? Good. And then cosine already is in terms of cosine. So usually what we do once we introduce other fractions is we usually just write it over 1. So we just remember what its denominator is. So we don't get confused about that. Over, what did you do with the denominator? Okay. Okay, so what can we do now? When we want to divide by a fraction, what do? We multiply by the reciprocal. Okay, so in the next step, I want to multiply by the reciprocal, so I'm going to be multiplying this entire expression by cosine theta over 1, okay? And that's going to take care of that. I'm going to multiply that entire expression by cosine theta over 1. So help me with that, Alex. When I distribute that to both terms in the numerator, what am I going to get? Okay, but don't show it canceling yet, just because we want to make it clear to everybody where it's coming from. So let's go ahead and just distribute it first, and then we'll simplify in the next step. Right, cosine theta, and don't forget to say the theta, that is part of it. So cosine theta over cosine theta, Okay, so we say cosine squared theta, because if you say cosine theta squared, it sounds like you're squaring the angle instead. So I'm not trying to be picky, just trying to teach you all these good things. Okay, and we already took care of our denominator, so we're just there. And I'm feeling good because we're getting closer, we're getting it simplified. Okay, so what happens in that next step then, Alex, you were saying? Okay, and that just becomes, ooh, careful. When it cancels away, anything over itself equals 1. So that term is not gone. That term is a 1, okay? And that's going to be important to us later. We're going to really need it, okay? So it's 1 minus, and what did you say our second term was? And do I need to write my denominator if my denominator is 1? So I'm just going to leave it as 1 minus cosine squared theta. Okay, was that helpful to us? We want sine squared theta. We've got 1 minus cosine squared theta. What do you guys see? What are you thinking? Remember, anytime I see the squareds, what I want to be thinking is about my Pythagorean identities. So take a look at your Pythagorean identities. The one that has cosine squared theta in it, can you manipulate it to say 1 minus cosine squared theta? Okay, so right now it says sine squared theta plus cosine squared theta equals 1. Can I manipulate it algebraically to get it to say 1 minus cosine squared theta? Sure, and this is an aside. This is not part of my proof, so this is over just on the side. If I subtract cosine squared theta from both sides, okay, the positive and negative cosine squared theta will cancel. That leaves me sine squared theta equals 1 minus cosine squared theta. Okay, so when I get to this point in my proof and I've got 1 minus cosine squared theta, what can I substitute for it, Alex? What can I substitute in there? Yes, because that equals sine squared theta by Pythagorean identity. And we did it. We did it. Very nice. Alex did it. I shouldn't be taking credit there. Good job, sir. Very nice. Okay. It equals sine squared theta. Questions for me on that? Make sure and jot that down. We learn by doing. You have to practice. Okay, we know how uncomfortable it is to sit there and struggle and not know your way forward. Some of you are getting this. You're feeling pretty confident. You kind of like it. You enjoy the puzzle part of it. Ms. Weaver loves that puzzle part of it. But I still remember how hard it was when I was in high school and did this unit. We all remember the pain and frustration, okay? So we're going to kind of try to scaffold you and get you there, but we need to know what your questions are. And if we lose you along the way, we want to get you on board. Okay, last slide. Questions? Are we ready to move on? Do we need a second? Okay, David gave us a thumbs up. Okay, last slide. Let's try this one. It says cosine theta over secant theta plus sine theta over cosecant theta equals 1. So this is a lot like that one we were just doing. So we're going to get a little more practice with those. Nice to get to practice the same things again. So let's try that one on the left. Ms. Weaver said she would go first. Okay. Wait, is this the same one? That's why I'm like, man, this looks a lot the same. I didn't advance the slides. So sorry about that. Okay, now let's try this. Okay, now we've got something different for you. Now we have something different for you. Sine theta plus cosine theta quantity squared. Okay, we're squaring a binomial there. A binomial is two terms, okay, and we're squaring a binomial. Now, how many of you can square that in your head? Can you make your Algebra 2 teachers proud? Can you do it in your head? To square a binomial, we square the first term, multiply them together and double it. So that'll be 2, because that's the doubling, sine theta, cosine theta. And then we square the last term. Cosine theta times cosine theta will be cosine squared theta. Okay, so I squared the first term, multiplied them together and doubled it, and I squared the last term. If you can't do that in your head, no big deal. We'll get you there, okay? Then go ahead and just write it out twice. Sine theta plus cosine theta times sine theta plus cosine theta. Because that's what squaring means. It just means two of them multiplied together. And then just go ahead and FOIL that out or distribute. Sine theta times sine theta is sine squared theta. Sine theta times cosine theta plus another cosine theta times sine theta. Remember, multiplication is also commutative. So sine theta times cosine theta is the same as cosine theta times sine theta. So that gives us 2 sine thetas cosine thetas. Okay? And then that last cosine theta times cosine theta gives us cosine squared theta. Okay? So that's my first step, just squaring that binomial. Okay. Now I want to get to 2 terms, and these are the 2 terms I want. One of those terms we already have. I stop and assess, where am I at, where am I headed? I want a 2 sine theta cosine theta, and I have it. So I'm like, score, okay. But I need to get a 1. So let's scoot all our other terms together out front because they have the 1 out front, and let's see what we can do. So we've got sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Okay, so I just brought that other cosine squared theta to the front. I just changed the order of my addition terms. Was that helpful? What do you see? What are you thinking? Zach, can you see anything? You look like you're thinking. What are you thinking? This is what we've got. This is what we want. Is there a way to get there? We want to keep this 2 sine theta cosine theta, so we don't want to touch that. Is there anything we can do with this? When I see the squareds, it makes me think about my Pythagorean identities. Okay, the one that has sine squared theta in it, what does it say? Zachary, what does it say? Do you have your notes handy? Can you see it? Okay, so we need our notes handy, or we got to write it out at the top of our page. The one with sine squared theta says sine squared theta plus cosine squared theta equals 1. And what do we have? Dun, 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 dun. Sine squared theta plus cosine squared theta. So we can substitute in 1 plus the 2 sine theta cosine theta we already had. And we did it. We did it. Okay, we got what they wanted us to prove. Questions for me on that? It's tough stuff, but as we start to see it, we'll start to get the hang of it and remember where we should be looking, what we should be considering, and we'll start to get it. You guys go ahead and try this last one for me. Now, these are not the same binomial. Okay, so you're going to have to multiply this out or FOIL it out. Or do you recognize, looking on that left side, what those factors are? Does anybody recognize the pattern they fall into? It looks different when we have trig words in there, but it is a pattern like you've seen from Algebra 1 and Algebra 2. What are those factors? They're going to make a perfect square. Those are the factors for the difference of a perfect square. Same first term, same last term. One has a plus and one has a minus. So if you recognize that, we know it's going to be the first term squared. 1 squared is 1. And it's the difference of perfect squares. Last term squared is cosine squared theta. That's going to be 1 minus cosine squared theta. Okay, now again, it's okay if you don't see that, okay, but we're trying to build those algebra eyes. I saw a lot of light and a lot of eyes out there. I think a lot of you were thinking about it, okay? So you can always distribute it. 1 times 1 is 1. Positive cosine theta and negative cosine theta cancel each other out. That's why there's no middle term. Negative cosine theta times positive cosine theta makes negative cosine squared theta. Okay, so just multiplying that out, difference of perfect squares. Okay, do you have your Pythagoreans out handy? Do you have them at the top of your page? Can we manipulate this one that I have at the top of the page? Can we manipulate it to get it to be 1 minus cosine squared theta? And by the way, sometimes you can't. It's so brutal. It's so close. Like maybe it'll have 1 plus cosine squared theta, and then you're out of luck because 1 plus cosine squared theta doesn't equal anything according to your Pythagorean identities. So just a heads up on that to be aware of that, okay? But we can manipulate this one to be 1 minus cosine squared theta. Let me see how y'all did in the meet. Let's see if anybody got it. Most of you haven't submitted your work yet. Make sure you submit your work so that I can see what you're thinking, see what you're doing. David, do you know what that's equal to? What is 1 minus cosine squared theta equal to according to our Pythagorean identities?
I forgot.
Okay, so are you where you can see my shared screen here at the top?
I can see it.
Okay, so it says sine squared theta plus cosine squared theta equals 1. If we want it to look like 1 minus cosine squared theta, we've got to subtract cosine squared theta from both sides. So when I do that, the positive cosine squared theta and negative cosine squared theta cancel. That leaves me sine squared theta on the left equals 1 minus cosine squared theta on the right. So what is 1 minus cosine squared theta equal to, David? What's it equal to? We've got 1 minus cosine squared theta on the right. It's equal to sine squared theta. So we can substitute that in. And we didn't do it. I thought we were there. We didn't quite do it. I was hoping we were done. Where do we need to go from there, David? So we've got sine squared theta, but we need to have 1 over cosecant squared theta. So what do you see? What are you thinking? Thoughts or ideas, David? You can do it. Too much pressure, he's out. Okay. See, when you guys don't share your slides, I just have to call on you with or without seeing your work to give you a chance to help us out. Okay. So Noah, what do you think? How can we get from sine squared theta to 1 over cosecant squared theta? What do you see? What are you thinking, Noah?
Sorry, give me a second.
Okay. We've got sine squared theta we just got sine squared theta, and I keep erasing, so sorry for that. We've got sine squared theta, and we want to get it to be 1 over cosecant squared theta. So if I erase this here at the top so we can see what we've got going on. We've got it to sine squared theta, so we're close, but we need it to be 1 over cosecant squared theta. So, what are you thinking?
Isn't 1 or sine squared theta equal to 1? Or like is the same thing as 1 over cosecant squared theta?
It is, because they were reciprocals. So we can just substitute it in. And we did it. We did it. Okay, thanks for the assist there at the end, Noah, coming through with the clutch save. Appreciate it. Okay, any questions for me on that?